And here we go. They didn't do a countdown this time.
Oh, so. All right. Well, no suspense there. All right. Well, we kind of already introduced ourselves a little bit.
We can do it again for fun for the users online, huh?
Yeah, we might as well. You go first. We're going to go Japanese style. Right?
Okay, there you go. I'm Harold Hannon. I'm the senior software architect for SoftLayer Labs, like I was telling some of the people here in the room. But for everybody at home, we do a lot of R&D work, proof of concept, tool selection, technology selection. So we get to play with a lot of fun stuff. Some of it works out, some of it doesn't. But we do a lot of making a lot of the things that we do easier, more up to date, go out, talk to customers, understand what the trends are, and try and bring those back and hopefully productize them. Sometimes we take input from our product management team and try and make something they've dreamed up real as well. So it's kind of what we do.
Curveball, how did you get started in computing?
How did I get started in computing?
Technology. Why did you get involved?
Originally? Way back when?
Way back when.
Way back
when?
What
was the original inspiration?
Cheating on games.
I like it. Like Game Genie kind of thing?
No, it was a game that I decompiled, and I went in and looked at the hex for, and I figured out where they were storing the money in the game, and I set my value to negative.
There you go.
Because it only checked for less than 0, so then I had infinite money in the game, and I was like, this is great.
There we go. Very cool. Well, I'm Phil. For people in the future who are watching this recorded, that includes them. I work at SoftLayer. I'm the lead developer advocate, and we help people use our API and do all kind of cool stuff. And we're here to talk to you guys today about this kind of cool thing that Harold and I put together. But don't want to spoil it too early. First, we'll talk a little bit about SoftLayer. We're an infrastructure as a service company. We've been around since about 2005. Infrastructure as a service for us, cloud hosting, means a handful of different things. It means bare metal, which if you were an infrastructure service, which used to be called web hosting about 10 years ago, you would have called a dedicated server. And then also what public cloud instances, or what we call virtual server instances. And that's kind of your traditional kind of public cloud shared environment, virtual machine type thing. Kind of the difference in perspective, I guess, that SoftLayer has compared to maybe some other providers is the way that we view the infrastructure, the actual tangible pieces of it all. For us, everything's pretty much a dedicated server. It's just a box with a hard drive and a processor and some RAM, and we have all these servers in the data center, and some of them we purpose for public cloud, some of them we purpose for storage solutions, some of them we sell wholly to a specific individual or company that wants the entire box in like a dedicated fashion. And so for us, it's all just kind of something that we can use to create these different things. We have 3 networks, which is kind of pretty cool as well. The triple network architecture is the way our marketing guys like to say it. It's 3 bars, so that's our logo. Yeah, and so public, internet connection, private, so you have kind of a routed back-end network, RFC 1918 addresses throughout all of our different data centers, so that way you can communicate privately between those data centers, between any of the servers that you own, and also we don't charge for that, so that's also a pretty big cool thing. And then there's a third out-of-band management network that basically gives you access to IPMI. So if for some reason you screw up your if configs and you can't get into anything, you can always go in through the IPMI or get into your BIOS or whatever you want to do there. Okay, cool. We have
Fair for marketing.
Yeah. I don't know exactly how many animations are here, so.
Yeah, they just keep on coming. And there's another one. Here, go to the other one. We got to just go for the.
No, I got.
No, see too much. Go back.
Okay.
There it is.
We got to go through them again.
There they are. We need to let collapse.
We need
This is most definitely made by marketing. You can tell.
There we go. All right.
There we go.
Yeah, we got through
there.
Okay.
It's all connected.
This is a map of all of our data centers as well as network points of presence. We have data centers pretty much all around the U.S., Amsterdam, Singapore. We just opened up Hong Kong? Where did we open up? Toronto. That's nowhere near Hong Kong. So we opened all those up together. We have a very large network, probably about the size of some Tier 1 networks. And the way we have all our POPs set up and the way we do routing, once you kind of hit one of our edge situations, we just route you in through, and you don't have to worry about the internet for the most part. So especially if you do something like cross-connect with the new direct link product. Yeah, so we're a pretty large company. We have about 21,000 customers. We were recently acquired by IBM, probably about a year and a handful of months ago.
Tell me about my birthday present.
And for Harold's birthday, it was a very special event, actually. Something near and dear to Harold's heart.
Yeah, January 17th.
January 17th. He wished, and it came true. IBM decided to put in
$1.2 billion.
$1.2 billion into the expansion of SoftLayer's data centers. That's right. Yes, that's how much they care about their employees. Sure. Yeah. So you can see 20 million active domains, 100,000 servers. We're pretty big. We've been around for quite a long time. SoftLayer and kind of a handful of other infrastructure as a service companies kind of came all together. I mean, by one name or another, you've probably been using our services, even if you don't know it, from the websites that you've been using for probably a good decade and a half. So we've been around a long time. And what we want to talk about today.
Yeah. So I tried my best to make this slide look kind of like one of those special boards that they have up at a restaurant. Kind of. I don't know. It looks close.
It's pretty good.
Yeah.
No.
No.
No. It was good effort.
Yeah.
Good effort.
Yeah. Like I said, I tried. Okay, so we're going to talk through basically traditional SOA application architecture. So something you would probably find normally in enterprises everywhere. Hopefully, you know, a little bit of review for some people. Maybe you haven't been around a lot of enterprise deployments. You're like, oh, wow, SOA, what's that? But hopefully we all know that one. Then we're going to get into cloud application architecture. So kind of contrast between the two. Show some of the similarities as well and the thinking on them. Talk a little bit about, you know, the implementation examples you might find in those, and then take a look at what we found from that, and then show you some pretty cool stuff with a fun application we made. Actually, this is all just a thing, guys, for this fun application we made. I'll be perfectly honest now. So let's talk about traditional SOA. So typically when we talk about a SOA application, we're talking about service-oriented architecture, obviously. So you've got a bunch of services with some kind of transport that's allowing you to aggregate those services together to do something useful with them. Typically, there's a service registry in that deployment that you go ahead and grab the location of where those services were, and you go ahead and use that algorithm you put together in your custom service that you put together, and you make something cool and fun and hopefully useful. And this is usually how it's actually implemented. Most of your application servers, things like that, had a sort of a directory lookup of some kind, UDDI, something like that. And then there's some examples. Maybe you had some network monitoring, some VMware, legacy DB. That's not your mom in the middle, message-oriented middleware for everybody. That was typically a transport that was being used. A lot of your ESBs, things like that. So that's typically what you would see for the actual implementation. So the good and bad of that, right? So you have absolute control of your deployment model. Typically these things weren't deployed in the cloud. You had them locally. So you got to choose when you did your maintenance schedule, all those sorts of things. The cost was usually a little bit expensive. Even if we're talking open source, the upfront cost of this, you're talking about capital expenditures. Usually if you got licenses or at least support licenses, it was a big upfront investment to put together these deployments.
That's more dollar signs than Yelp supports.
Does it? Yeah, yeah, yeah. I noticed, I was like, you know, I think this slide changed. I know you guys didn't know that, but I'm like, wait a minute.
That's a lot of
yeah, I think he added more dollar signs.
Well, yeah.
Anyway, so the varied resources, for local resources, you've got to have people that are there that are knowledgeable in those applications, right? Because you're maintaining them, you're running them. I've seen some pretty horrible things done with these things. I'll soapbox for 1 minute. I can't even begin to describe to you the number of times people took SOA to mean, I'm going to build every little piece of my application. You know, if I go to a database, I've got to go across the message-oriented middleware. You know, for one hit, oh, let's implement a for loop on an ESB. You know, those sorts of things. So sometimes you got some goofy implementations of these things. And then obviously there's the maintenance and what I just said, if incorrectly implemented, you can have a slow running application.
The good news is, though, it's not the only option that we have now. we have this new cool kind of commoditized type compute cool thing where, you know, it's all bubbly and we don't really know what it is. You don't really care about the infrastructure necessarily, right? And that's kind of like the big thing that I've noticed, at least is like this kind of movement to the cloud is it's just more and more abstraction away from the actual hardware. I mean, you know, a number of years ago, I was a sales engineer. Don't throw anything. One of the things that we used to get asked all the time was things like, what's the exact model number of the NIC card in your server, because our app only works with this very specific NIC card on this very specific firmware, and all this kind of weird stuff. And as time goes on, we have these languages that don't really care as much about that kind of stuff. And so that's kind of what's cool is that now that everything's kind of abstracted, you can kind of play with it a little bit differently. And you're not really tied down to the same type of hardware that you might have had to have been in the past. So a lot of these things that you used to have to go out and spend a whole bunch of money on, you can now kind of host in these different cloud environments. You don't have to do as much work typically, because if there's a service that's already handled video transcoding, for example, you don't have to write your own video transcoding service or throw up a whole bunch of servers with video transcoding. You can just use the third party, whatever it happens to be. And probably the best part is you only pay for really what you need to use. So if you only need some service for a few hours a week or a day or whatever, you can normally get some type of per usage billing versus kind of the traditional go buy $100,000 worth of servers model. Yeah, so back to some boring charts.
Yeah, I'm the architecture guy. I got to do charts. Okay, so I get paid by the slide, so I repeated a slide. But when we're looking at it, just saying it's basically the same thing, but it's cloud services now. Same sort of idea. So when I look at the way this has evolved, right? So cloud started out, it was kind of in its infancy. People were kind of doing their own thing. And over time, if you look at some of the leaders in the space, if you look at like a Netflix or somebody like that, they're starting to get things. You got the Asgard put together. To get people putting together Zookeeper services to keep track of where things are, Eureka, things like that, to actually put together a service registry. When you start to look at what it's doing, it starts to look like MicroSOA. Start to hear a lot of people talk about MicroSOA. And it just strikes me as it's very similar. It's got the transport, it's got the services, has a service lookup. So we're sort of looking like the same sort of thing here with this implementation, but it sort of morphs. Oh, there's the fancy slide where it dissolved. So like I said, now you might have a queue service, object storage, some sort of VM appliance that you've put together on a cloud server. And we're using sort of more of an internet sort of transport there in place where we used to have an ESB or a message-oriented middleware. Sometimes public internet, sometimes you've got private network behind it. And once again, we're using some way to look something up, go figure out where that service resides. Sometimes it's low balance, obviously, for high availability. We want to be cloud-like, right? And we're doing the same thing with it. We're kind of stringing these things together to put together a logical application. Very, very similar to the same architectures. The nice thing is, though, right now it's all about the integration, right? So the focus starts becoming how do I integrate these components? So it lessens the code base. There's less maintenance. That's good stuff, right? So as a provider, it's not just enough anymore to just give just an instance, right? You're starting to see more and more services pile on, more of a PaaS type offering being offered, the queue services, the object storages, to keep layering it on. As cloud instances themselves become commodities, it's important for providers like us to say, okay, what else do we have? What else can we give you? So you're seeing far and far less code needed because a lot of these services, or even deployments, you don't have to deploy your own message queue onto a VM instance. You've already got one there that you can use. So it really, really helps with that. So let's go through a use case, and I'll go ahead and take something that's probably near and dear to people, especially with being DevOps people. So detecting an event that's triggering, something happens, right? And posting that to a queue, and then based on what happened and that triggering type, creating a VM instance. So maybe your triggering event is resource load or something like that. So we're talking like an auto-scale type application. And then we want to audit that in some way, record that transaction. And then make it viewable somehow, right? So we're going to kind of walk through this use case and sort of contrast the way it had to be done before versus this cool thing that we did.
Harold, would be useful is maybe a chart.
A chart, yeah. I'm an architecture guy. Prepare yourself for a chart. Okay. So, wow, that one didn't scale right there. Cheetos adapter.
To be fair, I did open a PPT with Keynote, so.
Yeah, that my fault for PPT and on the Keynote.
Yes, you should keep
Yeah, that's not good for me. Anyway, so since we got acquired by IBM, why not put IBM stuff all over for this OS stuff? Because it's very enterprisey, and they would like that. So if you put together that use case I just said, maybe you've got something like, we were talking about Nagios earlier, NIMSoft. So you've got something like that out front, monitoring things. And it's spitting out events into everybody's favorite IBM MQ series. You spent the dollars for it, and you got it, and it's up and running, and put it on your machines. And you've got WebSphere running, and you've got your UDDI, and you've got some code running there, and you're storing stuff in DB2, and you've got your VMware cluster all set up, and you're spinning up and down instances based on what's going into the queue and what your app's running, and you got a custom web page you've deployed, and you're looking at everything that's going on, and that's great, and you're probably several $100,000 in at this point, but you've got lots of capacity and you're ready to go when times get tough and you've got a lot of resource load on this.
So I'd like to talk to you guys about science.
Yeah.
Science is near and dear to my heart. I like science. I think it's a lot of fun. I watch The Cosmos, Carl Sagan's and Neil deGrasse Tyson's. Listen to Star Talk. And I just think it's really important that we find extraterrestrial life. And to help out with that,
Hadron Collider.
We have other people in the SoftLayer team that have different points of view on what is important to study in science. He likes the Hadron Collider. So we thought, how do we show this concept that we're trying to work with, the scalable application? How can we put together a nice, fun little application that will also help us decide once and for all what's cooler, finding an alien race or the scientific equivalent of hitting rocks together. And so what we've done is you guys may remember SETI at home. Yeah, anybody remember the screensaver? That is still around, and also CERN, the people who have the Large Hadron or Hadron Collider, depending on how you like to say it. I think Hadron's correct.
It's very cool.
In any case, those projects are still around. Great computing projects.
Boson, God particles.
Gotcha. And cool news, they both use a client called Boink. And I'm going to let Harold, as this is a chart.
It's a chart.
Describe.
You can do the next slide if you want. It's not a chart.
I'll do the next one.
You want to do the next one?
I'll do the next
Okay.
one. You can get
Fine.
this one.
Okay, cool. So what they ended up doing was they took the SETI concept, and as Phil said, it's the Boink client. So what a better way to kind of demonstrate scaling in cloud, right? So it's sort of crowdsourcing compute. So what you do is you can get an instance up and running of a machine, and you can install the Boink client, and then you just pass it a project URL, and that configures it. You have to have an account, and then you say, that's who I want to dedicate my compute to, and they load you some computation packets to do, and you do the local compute on them, and then you pass back the results to them, and they aggregate them together, and it's very, very cloud-like. So
it's like Dogecoin mining for science?
Yeah.
Okay.
Definitely, same kind of thing. Same kind of thing. So, that's the nice fancy chart, but
the end result is you get a whole bunch of computers all communicating with a server, and all these computers they're just doing work. They're doing arbitrary math, and the server makes sense of it. Exactly, and as I mentioned, we have very differing views on how we should be spending our resources, and so we came up with a little bit of an idea. We figured, why not let everyone that we talk to at conferences and meetups and everything help us decide? So what happens here is if you pull out your phone.
You're going to cheat again. Did you cheat?
I didn't cheat this time.
You didn't cheat this time?
The effects of my previous cheating is still there, though. So if you were to pull out your phone.
Pull out your phone.
Your phone or your book.
And you were to tweet. some type of message and include the hashtag SoftLayer for SETI
or SoftLayer for CERN.
SoftLayer for CERN, what will happen is our application will go see that you have done this, and we will create a virtual server instance on SoftLayer's cloud for 1 hour doing grid computing for your chosen project. So you can help advance the human race by finding artificial intelligence.
God particle.
Extraterrestrial intelligence.
God
they
particle.
probably have artificial intelligence as well, though. So I'm going to do a little tweet real quick. Harold.
We'll lose, right, or something like that. Just for the record, he cheated last time. Everybody at home, he cheated. His tweet like multiplied like 8 times or something. What was it? It just spammed the entire queue. Very conveniently for SETI. Okay, so how did we end up doing this, right? So we showed that other architecture, and I know it was very boxy and blocky, and it wasn't any fun and wasn't exciting. So I put together a cool, I'm going to say it, buzzword time, everybody get out your bingo card, Web 2.0 looking kind of,
Oh.
Yeah, there we go. Got that up there for the slide. So obviously, you know, you could put Nagios or whatever you wanted in front of this, but for fun, we put Twitter in front of it. So that's the thing that we're using to detect our events. There's Twitter events. But it could be anything you wanted it to be. And it's feeding into our queue service. Every time you tweet, it goes out and does a query, kind of grinds through it and pulls it in, puts it on the queue. And then several different things pop it off the queue. We have something that makes the VM, so it makes a decision, a little bit of code says, oh, that's this tag, that's this tag. We have an image of each one of these, so we set one up, and then we took images of them, so it just very simply takes that image and makes an instance. Takes your wonderful picture that you have for Twitter, everybody behave yourselves, stores it in object storage, and then we put that on our dashboard next to your tweet. If it's working, is it working? It's working. Yeah, all right. And then we have a Postgre database that's sitting down, and it's keeping track of all these transactions, sort of acting like a log, keep track of things. And then obviously the UI goes in and looks at object storage in the database and does its thing.
This could be anything. This could be the $100,000 solution that you've built inside of your personal data center, or this could just be a server in your garage with a whole bunch of web services. It's really the architecture that's quite interesting behind it. In our particular instance, we chose to leverage as many third-party SoftLayer services as possible.
Imagine that.
And turns out they're free for us.
Yeah.
So we didn't have to do a whole lot of work to get most of this stuff working. We already had a queue service. You know, we already had storage. We could utilize all of these things that already exist. One of the cool things that we used was our Python API, which we've kind of used to simplify. I know Chris described our API as arcane a little bit earlier, which makes, I think, me a magus. I think I'm going to change my title. Magus, is that? Magi. That's multiple of mages.
Yeah, no, I wouldn't.
Okay.
You don't split yourself.
Okay, fair enough. So one thing that we've done is we built a Python API with a number of different managers built into it, and these managers kind of obscure some of the complexities of our API. And on top of that, we've built in a command line tool. So you can just do something as simple as pip install SoftLayer, configure it with your API key and your username, and then you're off to the races, as somebody might say, but not normally me. I don't know why I said that.
No, yeah. And this is part of that whole thing that we were talking about, where we're trying to do value add on top of just having just your basic compute for sale. It's a great way to differentiate, having things to where you can simply bring things up and down, put together some shell scripts for automation. So.
Yeah, and so real quick, here's just a quick example of what this looks like using that tool. This is going to be very similar to what you would experience at any provider. So, I mean, we're using SoftLayer as the example here, but plug in your favorite cloud of choice, right? But you know, you just fill out some very basic information from the CLI here. It looks very, very similar, except we still need to put the image ID in that old one there.
Oh yeah.
Big old long hash looking thingy is just the image ID for the different image templates that we have for SETI.
I think it's the headrun.
Of course,
image
it would
ID.
be.
I made the slide.
The cool thing about doing things this way, trying to utilize the cloud services, trying to make things simple, you can do it pretty small. So about 300 lines of code, 15 functions. We probably could have made it a lot smaller.
A little sloppy, probably.
Yeah, it's a little sloppy. I wrote a lot of it, so that's...
It's a marketing project.
Yeah, exactly. It didn't really have to work all that well. It just has to work well. It's pretty simple. We did 4 cron jobs because we were lazy. We could have made this a lot better. But we spent like maybe 10, 15 hours on it.
Maybe.
And most of it was on the cool UI you're about to see.
Yeah, and that's auto scale. I mean.
Yeah, exactly. All of the virtual machines that we're pulling up to do all this work, 1 gig, and I guess it's just the smallest amount of storage that we offer.
CPU 25 gig, I think, for the disk.
And it's also what's running all of the workers and all that kind of stuff. So it's pretty simple stuff, right? And I guess let's show you the little dashboard. And you can see this is when Harold was cheating.
I was, yeah. I taught him how to cheat, and then I stopped. He's not honoring the ceasefire.
Alrighty. Whoa. Uh-oh.
Hey,
Responsive UI.
right.
Look at that.
Now you know who to vote for.
Okay.
Expand.
Yeah, let's do something like this maybe. Oh, this is nutso. Maybe we can get all of it. Ah, there we go. Cool. All right. Did anybody? Oh, look at that. We got some. Look at this. Oh, poor Harold didn't get any votes today. Oh man.
I hate all of you.
That is, isn't it? Just flicking dirt everywhere, you know? Good job, gentlemen. Good job. Yeah, and so this
We're all
is just
gonna die because we're looking for ET. That's it. I'm leaving.
But yeah, so this is just reading off the Postgre database that we have, which is kind of what we were using for logging, right? I mean, ideally, I imagine you'd have something much more intelligent going on for log management. But we wanted to put together a nice, simple example to kind of break through this idea of kind of using different types of services rather than what I've always referred to in the past as like enterprise-style hosting.
Oh, Pippi Longstockings voted for me.
Yeah, I noticed that. That's who's Pippi Longstockings? Anybody? Nobody's. No one's voting for that one.
Nobody voted for me? I'm out of here. I'm not even doing this anymore.
We'll have to check that. We should put a timestamp on this.
That's true. We should.
Like 2
Some
hours
random
ago or
person
something
just
like
voted
that.
for me.
Yeah.
Wait, that kind of looks like me in the picture. It wasn't. No, I didn't.
It is weird though, because since it's like a tweet every once in a while, just somebody who has nothing to do with us will retweet it or something like that. It's kind
randomly
of
shows people.
And I really thought that SETI or CERN would notice us, but they haven't yet.
We should probably just tell them.
That'd be a good idea.
Yeah. We might get some publicity on it.
Yeah, that'd be a pretty cool idea. Yeah. Okay. And then let me show some code, I guess.
Yeah, let's show.
Did you take the credentials out of the?
But we have the other directory.
Did you?
The clean one?
Did I?
Yeah, you got a clean one.
You sure?
Yes. CD into it.
Let's
C and then D. Hey, I didn't get any votes, man. I gotta take that out with somebody.
Oh yeah, UI was built in Flask, which is pretty awesome. Anybody use Flask? All right, very cool. I mean, I learned it from 2 of the people who raised their hands. So, we have 2 search little scripts here. We'll look at the CERN one. Wow, my MRC is not set up, it seems. But in any case, pretty simple application, really. Man, I forgot how hard it is to read code when it's not highlighted. There we go. Yeah, so it's pretty simple. I mean, with Twitter, it was kind of interesting, and of course, this is esoteric details about Twitter API that doesn't really matter. But you can't really do a search by time frame in Twitter. The only thing you can do is search since specific Twitter ID. So kind of like the Twitter stream, as they call it, is actually the timestamp. And so we have to store a log value of actually when the last tweet that we searched was. And then we just basically search through, find any instance of the hashtag that we're looking for, do a whole bunch of, see, there they are. Yep. I told you they were in there. So now we got to change those.
You voted for him.
And then we just create a message in a message queue. and we just have these workers. I'll show you the workers. Hopefully they also have 2 credentials. This worker here is basically just chugging through. Man. Okay, those are good. Those are
No,
oh, there it is. Yep. Change the
There
database
we go.
password too.
Not there.
Store your configs in config files, and then
When you're giving a
and then
demo,
load them in to your.
That's a huge
If you're going to take away one thing.
taking screenshots.
Yeah, this
you're
is
welcome, Internet.
Yeah. This is just a worker. It's just going over and over, looking to see if there's a new message in the queue. When it sees a message, it's doing all that work we talked about. It's reaching out to that database. It's storing a whole bunch of information. It's getting that picture out. It's actually creating the virtual machine using the SoftLayer Python client. It's storing a whole bunch of information, putting it all in the database so that way our cool little UI can display all that information. Really not too crazy complicated. I think it's probably the most interesting stuff in here. Unless you just want to look at our database schema, but it's just a database. I didn't think so.
This is mostly just so you can tell that we're not horrible liars. And we didn't write too much code, and obviously we didn't do a great job doing it.
But yeah,
Yeah.
stats.
So how are we doing? Yeah, stats. I love stats. Yeah, so we talked about a couple of these. Maybe under 20 hours easily for construction, and that involved a little beer drinking, I think, every now and then. Yeah, sometimes we pretended we were typing and we sipped.
I thought about that.
Yeah, I did too. Kept things close for a single provider. So one of the interesting things when you start talking about the cost on this, if you're doing private traffic, if you happen to be hosting at SoftLayer, yeah, we have all these services, and you're on the private network. So we are not going to be charging for the bandwidth on that. That can help on performance as well as with the cost. So if you're aggregating a lot of things, if you happen to have a provider that has these services, great. It's a good idea to use them. Don't go running around unless there's a really good reason to pulling them from a bunch of different places, because you're going to be hopping zones or public interfaces, whatever they end up being. So here's the grand total. This is where the fun part comes in, because the title did say profit. It did say profit in it. So each one of these is about 5 cents, and most of that's for the compute. So 4 cents for the hour, less than a penny for the message and the storage for that object storage and the message to be published. Didn't get any bandwidth traffic on this. I mean, with the public instance we use for the dashboard doesn't get enough traffic to even touch a cost for that. So I think we've spent more than 50 cents now. We probably need to update that one. We're probably up near $1 since we've been doing this. So as you can see, that kind of is a huge contrast between if you were just stepping in to do an auto-scale application, that sunk CapEx cost versus obviously the transactional cost here. So you can sort of scale with your resource needs. Obviously, a lot of the cloud deployments are more revenue-backing kind of use cases. So you find more that people want the cost to scale with the actual application, because generally if you're loading more resources in, you're probably making more money on the front end as well, since it's revenue driving more often. So it's a little bit of a contrast there to the enterprise mindset, which is, you know, spend a bunch of money up front and that's a cost, and we'll make up for that in other areas. So that's all that cool stuff.
Cool. So one of the ways we organize things at SoftLayer is in this kind of pod design. That's also kind of how we built the application. So it's a loose analogy. Basically, we have these pods, as we call them, that equal about 5,000 servers. Each one of the pods has its own networking row. Each one kind of has its own modular kind of system. That way, they're all, for the most part, autonomous units. So, you know, some type of outage on one pod should affect the other, that type of thing. And each one kind of has its own holistic set of tools and services inside of it. And this is very similar to how we typically do application design as well. And so you're building kind of these different silos and these different types of containers. And what's pretty cool about when you get to a point when you're scaling these types of things, you get an idea of, you know, this many web servers, this many database servers at this different size equals X number of customers or X number of users. And you get to the point where you can kind of pod those up and start deploying these big units of things. And configuration management tools and all that kind of stuff come into play at that point. What we were using for this was just a pretty simple imaging system that's built into Zen, the hypervisor, so it's nothing too fancy. I was going to actually set it up with Chef over the weekend, but I got busy, so I didn't have an opportunity to. But yeah, I mean, it could easily be translated to a set of Chef scripts or even something like salt stacking. It's all pretty simple stuff.
Yeah, and this isn't synonymous with a zone. We don't really have the idea of zones or anything like that, so deploying anywhere within one of these pods, we don't consider any sort of traffic or anything to be different or costs, or we use a VLAN strategy, so the way we secure things is based on your deployment with a VLAN, and you can spread it across these pods across any of our data centers. So there isn't any sort of configuration that needs to be done there.
Cool. So,
You, me, which one of us? You want to do it? I'll do it.
you do it.
All right. So the traditional best practice architectures, they still sort of apply, right? So we have the idea of the SOA deployment becoming micro SOA. Same concepts, we're just talking about them a little bit different. So instead of having those services for SOA, we've got cloud services that we're aggregating. And it's a lower cost of maintenance, obviously. We've got the just the lower footprint of the integration code and the wealth of services that are being provided now. And obviously, if you can have somebody, once again, like SoftLayer, that has hybrid hosting, so it has the physical servers as well as the virtual, as well as the actual services available. If you look for providers like that, you have a lot more opportunities to maybe do a little bit of hybrid, have a big data solution on physical hardware, bursting scale with cloud compute instances as well as all the services.
Yes.
Are you gonna get to the good part?
Yes, we are. He couldn't resist. Yes, I will, Kevin Landreth. You're welcome, Internet. You can get them. These are the links. We highly, highly, highly encourage you to go ahead and check out all the docs for our Python, CLI, and our API, as well as hang out in the forum with Phil, the illustrious
Magus.
Magus, yes, Magus, of the forums. He will talk to you. Or type at you.
IRC as well.
Yeah.
Channel. Freedom. Yeah. Anywho, any other questions?
Other than when we get to the good part. See, you needed to wait for the question.
You mentioned pods and Zen hypervisor. So basically, Zen has a concept of pools. Is there, like, I mean, is the storage, basically the kind of, I don't know, how much, how much is the failover capability is there storage-wise in terms of pools or whatever you have?
It really depends on the offering. We have two offerings for kind of storage in our public cloud. We have like a SAN-based storage, and then we also have local host storage. Local host storage, it's some RAID. I don't know if it's 10 or 6. Is it RAID 10? It's RAID 10. So the redundancy of RAID 10 in some instances, you could lose 2 drives. But if the physical host were to get hit by a meteorite, the data's gone, right? With the SAN storage one, you're going to have a little bit more redundancy because you have whatever redundancy is built into the SAN itself, which is typically a lot more. Whenever you're working on like an app or Ecologic or whatever it happens to be. And of course, since you are booting off of a remote device, something happens to the physical server, the host server, you can just fire up the instance on a different host. So you can kind of play with it because you lose a little bit of performance by going to the SAN, just because you have more neighbors that might be using up some of the IOPS, but you lose some redundancy if you go with the local storage. Yeah, and our public cloud is all based off Citrix Zen, is the hypervisor there. Yes, sir.
So I found your Python API a couple weeks ago. It was great after trying to read through horrendous docs of
The others?
Yes. It was overwhelming.
You have my email.
You have some of the authors in the room, and they're very proud of themselves for that statement you just made. So.
The Python API. The Python stuff.
Yeah, about the Python. Yeah. The Python stuff. Yes.
The Python stuff is great. The whole like Java, whatever the other one was, I'm like, I just want a curl example. I couldn't figure that out after several emails and conference calls. Anyway, back to the question. On the Python API, is there a way to just like output that in XML or simplified format that you're aware of? I looked through the docs briefly. I didn't see a way.
You just want to like get.
I just want to output it simply so I can easily parse it.
There's actually -- format.
You listen?
No, if he just wants like JSON back.
Yeah, you could do JSON output of the commands. Do you want the actual API calls? Is that what you're asking for? Or?
No, I just want the
data.
output so I can like put it into Ansible
Yeah.
and inventory scripts like on call.
-- formatting is JSON.
Yeah. Does it support XML as well? No, just JSON right now. And raw, like text.
Yeah, well, it'll be tabbed and limited. So.
Okay. Yeah. We can always add in one. Yeah.
You can always open an issue.
Open an issue on our GitHub. Yeah. Yeah. Well,
People in this room will look at it.
yeah. Actually,
That's why I said they're happy. They're like, yay, Python.
you have the
People like
majority of the people who commit to that project in the room. So, yeah, absolutely. And shoot me an email if you have any trouble with it. I'm happy to send you over an example. And I don't know who you had conference calls with, but we're the guys that can help you.
Yeah.
So definitely shoot me an email and we can chit chat. Yeah, yeah. Cool. What else can we answer for you guys?
Not him.
Second question.
What did you use for the messaging? Those just on your setup. I was trying to. I do the hourly cost of my tests at 4 cents an hour, so I'm well aware of that point. What do you use for what messaging services? I guess do you have?
So SoftLayer just has a messaging queue service. I think it's proprietary.
Yeah, something we built.
But it's a full REST. It's not the same kind of API that you
Yeah.
for the rest of our services. It's much like our object storage API. So it's all REST or REST-like.
Yeah.
So you can actually just use in the documentation there are a bunch of curl examples as to how to push message create queues and push message.
Yeah, take a look at the message queue documentation. It's probably more your speed, actually. It's a little cooler.
It's pretty useful. Lots of code examples.
That's
Very
good.
simple.
Yeah. The other stuff for spinning up instances is like, felt like brain surgery.
Yeah, most of those.
What is Ubuntu 12.04 that's on that one?
Most of those code examples exist on my GitHub right now. You know how searchable that is. Actually, right now, one of our developers, Cassandra, is working on the next version of SLDN. We're upgrading to Drupal 7. It's all based in Drupal. And one of the things we're building is a code example library to make things a little bit easier. Being able to like have links to code examples for method pages and stuff like that. I feel your pain. I use that website probably more than anybody in the world. I go through it every day. So yeah, we're always trying to find ways to make it better. So yeah, definitely shoot me over whatever ideas you have. I'd appreciate it. Yeah. Cool. What other questions?
So, well, you had all those pictures about, like, when, your sites in Hong Kong, Toronto, everywhere. So, well, basically, the old problem of, is there like a reasonably, well, basically free, not reasonably priced solution which basically provides, some kind of, relatively, non-eventually consistent, meaning asset-like, behavior for data store. Other than shelling out big bucks for Oracle, or they supposedly have very good clustering solutions. But are you guys using it anything internally, or aware of anything, providing anything?
Like a you question, right?
Yeah, well, it depends upon your data. Obviously, if you're wanting eventual consistency.
Actual, well, more or less, within.
Yeah, well, I mean, if
physics
you're talking, physics limits, you're talking across the world. It depends upon what you're doing. I might grab a NoSQL or a Maria or something like that instead. Like I said, it depends on your data set, what you're using, if it's structured or unstructured.
Structured.
It's structured?
Right.
I've got Maria with Gallery, I would say it working.
Gallery.
It's like, okay, how do you San Jose and Dallas?
Right.
That lag, it's like, okay, got any smart slave flips or something.
Yeah, that's why I was saying some of the NoSQLs have already built in more of an asynchronous that's meant to deal with some of the latencies you can experience when you're crossing large geographic areas like that.
How structured data are we talking about? Are we talking about relational data? Or?
Yeah. But it's not a very heavy write intensive, like, it's essentially, inventory type stuff. So, I mean, in the sense that it's not, just being hammered, but there is like a 0.1 second say, like I mean, right now we're thinking of basically Postgres with pooling software and things like that. Okay.
Yeah, that's a good one. Just as an FYI, we looked at doing Oracle, like you said, shell out the big bucks for it. And most of their geodiverse type, like long distance replication is basically a messaging application in the background that just shuffles back and forth the changes and does conflict resolution, things like that. So we were running Oracle internally, and we looked at it. So that's why I was like, well, you could shell out the bucks for Oracle, but realistically, when you look at the implementations, it's not that different than a lot of the other open source, both the big data and structured data, RDMS type applications. They're all, I mean, it's really the only way you can do it. You can't wait to have those happen. So they're always some kind of asynchronous message updating back and forth kind of thing.
Cool. What other questions? We love answering questions. So. All right. Good.
Well, you have I think a Mongo solution. What other NoSQL solutions that you have kind of out of the box? And I haven't had
Riak, Mongo, and Hadoop via Cloudera. The Riak and the Mongo actually install an instance, will get you clustered and all that sort of stuff. You can do the topology, and it just does it for you and hands over your logins when you're done. The Cloudera Hadoop one, you just tell it, basically the sizing you want for it, and it gets all the agents installed, it gets everything connected, and then just dumps you into Cloudera's management tool and lets it do what it needs to do. Mainly because we didn't want to try and rebuild Cloudera over top of their API. It just seemed kind of ridiculous. So they are good at what they do. So we just hand over the keys to that one. Here you go. Here's ready to go. Configure it. Cloudera.
Do you have any hourly instances for that? One of the things I ran into was like trying to test load balancers. Like, well, you have to purchase it for a month, and then we can reimburse you and all this. And I'm like, US does it now. So that's like.
No, I think those. I'll have to check. They might do hourly with those, with some of them, because I know they based them on the bare metal instances, which do hourly. I just don't remember if actually on the product they said those as well are done by the hour. But if not, you can always spin up. Well, you probably just want to kick the tires on physical.
Well, part of it was like the load balancers. I want to test them, but it's like, okay, you got a whole month, not a whole lot.
Yeah.
$50, so it's like proof of concept. I just want to go play with it, and no one's going to notice 5 cents on the inputs. But $250, I'm going to go.
Yeah,
nobody will notice that.
You might want to go with one of our virtual instances because, I mean, the way we scaled those was we went with like production type hardware requirements.
Load balancers. I was talking about like your physical load balancers.
Right.
I would put like HA proxy on.
Right. Yeah, and I'm saying like if you just wanted to kick the tires on big data stuff, you probably would want to lean towards a virtual instance because even if it's by the hour, those are like production class machines. So what we did was we worked with all the vendors and said, here's our fleet. What do you think's the best config? And so they're really meant more for production purposes. So I don't think I'd spin those up for just sort of a POC. Hey, how does it look kind of thing. Yeah, no, I wouldn't do that at all. If you want to keep things sane as far as performance, make sure you get local storage.
I've learned that.
Yeah. yeah. Well, I mean, if you're doing anything that's I/O intensive, the IOPS.
We were actually like our web server 4 years ago when that came on. We tried that. I was like, okay, we can do this stuff. Like first month of testing.
Yeah, the local disk is going to be much more performant.
Cool.
So, well, just one question. Basically, you mentioned you have a proprietary messaging solution. Or are you guys thinking of, in the future, branching out toward more, OpenStack like, open source stuff? What are the internal, infrastructure-wise plans? What's
Object storage is Swift.
Yeah, we do have some OpenStack stuff. We also have a project called JumpGate, which is kind of like a translator for OpenStack different APIs. On the internal side of things, a lot of SoftLayer's data automation is proprietary. So, I mean, if we were to switch over to something like OpenStack, it would probably be a pretty long process. SoftLayer's was in business for a long time before OpenStack was even a thing, and it's just now kind of become a standard. So you can't really just switch the entire internal infrastructure every time the hot new topic comes up. And so it's one of those things that, in 15 years or 10 years or whatever it is, if that's the standard of the internet, obviously we would consider moving to something a little bit different. But I mean, right now, most of the stuff, like I said, is proprietary. We're always looking for ways to improve that kind of different stuff. And actually, some of the people in this room hammer at that kind of all day, trying to figure out how you make provisioning faster, how you do all that kind of different stuff. So it's just one of those things that, you got to take it day by day and kind of see where everything's going.
Yeah, Jumpgate's really cool, though. It's just sort of a modular plugin. Front end looks like OpenStack. Back end is whatever people have developed plugins for.
Is that Python? No. Is that using the Python bindings?
You actually don't know, or are you saying?
That's a great question.
I wasn't actually on that one.
That's true.
You and that other guy did all that.
Yeah.
I don't really
More
remember.
languages than that.
What was the question?
What language is Jumpgate?
Other than the
What
comment.
language is Jumpgate version?
Yeah,
Yeah.
Python. Yeah.
No, but it's not Flask.
It's not. No, that was.
No, it's Falcon.
That was
so
Slick.
is that the question?
Yeah, that was a real
About
question.
Falcon?
Slick
Yes,
was-
it's actually based on a library that Raptor uses, which is funny. I guess.
Flask. We have a open source portal called Slick, which is built with Flask. Yeah, that's where we're at. Then.
Yeah.
And we're also working on a Ruby client as well. That's supposed to be a little bit simpler. So if you're a Ruby fan,
Stay tuned.
yeah, exactly. There's already like a first version out. So yeah, it's got a handful of different aggregator classes, big old Ruby things.
You guys thought about contributing to Fog?
We already have.
Have you?
Yeah, actually, we were the first. So Fog decided to change the way that they were doing their modules. How it used to work is you would fork the entirety of Fog, build your module in, and PR it directly into the giant Fog repo. And what they decided to do is move to a model where each one of the different cloud providers or vendors was its own individual repo. And so we were actually the first individual repo in the kind of new model. So we kicked that off maybe 2 months ago. And,
Okay, that's Fog, because I remember checking 8 months ago going through the API talks, and I'm like,
it's pretty new.
Somebody else made something easier.
Yep. Yeah, we did that, and man, I want to say it's either that or our knife plugin that we recently released. It's downloaded like once every 30 seconds or something like that. It's been incredibly successful as far as I don't know how many people are actually using it, but at least downloads. We need to track actually, take a look and see how many people are actually making calls with that kind of stuff. But yeah, I mean that's one of the things that my team is really interested in doing is finding third parties, cloud libraries.
If
all
you
that kind
guys
of stuff.
did it, but Ansible, the 1.7 release earlier this month, they released SoftLayer.
I don't think that one wasn't me at least. We have a lot of friends at IBM though that do that kind of stuff. SaltStack we were heavily involved in. I got to commit some code to that one. We're also in LibCloud, JClouds. We're about to be in a Puppet. Not Puppet. It's I don't know how to pronounce it.
Fit. Yeah. That's,
The PHP thing.
Yeah, the Magic Dragon.
Yeah. So it's like a PHP GUI for Puppet kind of thing. So I've been working with the maintainer of that project to get SoftLayer also added onto there, which is all Vagrant based actually. And so there's a Vagrant plugin somewhere for SoftLayer as well. Actually not written by us, but it looks pretty good. So yeah. But yeah, so that's one thing that we're really trying to get more into, and we're just to the point now where we're starting to build out that team of being able to get more involved in the third-party projects and really get our hands dirty. So, yeah. And like I said, shoot me an email. I'm happy to. We'll throw developers at it. Yeah.
Literally.
Yeah, actually.
Budget throwing.
We have a raffle every day for
Yeah, exactly.
Go to developers.
Run by Jeremy.
Yeah. Cool. All
so
right.
you guys out of the alpha office?
I am.
Yeah.
No.
From like here over. Here over.
You were at the
Yes.
Bastio meetup last
Mhm.
year.
Yeah.
Last year.
Yeah.
Or is it probably like this year or next year.
No, yeah.
I've heard rumblings about us being here again. So.
Yeah. Go to a bunch of them.
Yeah.
Yeah, I probably did my. Be sure to put big data on bare metal. It was the everybody was running around yelling at all the big data application developers, telling them that their application stunk, and they're like, you're deploying it on network attached storage on Amazon. What do you expect?
And I think we also do the PHP Texas meetup. Is that what it's called? Texas PHP?
It's just PHP meetup.
Is that what it is? Yeah.
You was to where?
I think it's at our office
At
here
our
at the
office.
Alpha. Yeah.
Yes.
Which is meeting.
Yeah, it's normally pretty big. Yeah.
Pretty nice.
You know, having full everything every time.
I know.
Yeah, that's pretty cool. Chris and I are actually in Houston, so we haven't actually gotten to get up to that one though. But that's pretty cool. Yeah. We drove up just for this, man. That was a good time. Thanks for having us.
Thanks a lot.
Yeah. Cool.
Bye, Internet.
Sure.